Hello everyone, I'm Abasu and welcome to my course on communication and network security. In the last session, we have discussed about the TLS handshake, how it sends the data, and how it makes sure data packet has not lost and it received by the receiver, and what is this process. So in this session, we will be starting to looking into it the encryption at a transport layer. So this is where or is use SSL, but of course SSL has been appreciated or removed now and replaced with TLS, that is transport layer security. So let's say a client wants to go to a bank server, they send a clear text to HTTP traffic to www.banking.com. The banking websites say, oh, let's wait for a second. If you are going to do online banking to go to encryption, so I'll tell you what, I'll send you back my certificate, and this certificate which we know is set up according to the standard, that is X.509. Today usually version 3 is used to ensure that this public key belongs to the bank. It issued by a certificate authority. When the client receive that, it open the certificate, validate the uh, digital signature of the CA and extract out the public key of the bank. Then client choose a session key, initialization vector, and in some cases an HMAC value, encrypts all of that with the bank's public key. This is a asynchromatic cryptography. The bank is the only person who can open this, because as we know, anything encrypt with a public key can only be decrypted with a corresponding private key. So now bank has a copy of this uh, this this session key and initiation vector. Now we can set a communication between client and the web server, and all of the communication will be encrypted using the session key. Now that is obviously a synchronous encryption, because it's a key that's used at both the side. It's only going to be used for this communication session and then discarded when the session is finished. So we have here one way of setting up TLS. We can also set up some Delphi elements and other doing key negotiation, but this is how many banks even today do this using using, for example, RSA. There are many different types of transport layer attacks. We looked at sync flood before, and just flooding out a victim so that they are receiving many banks even today, receiving many banks, maybe thousand of the sync request per second, that they cannot possibly handle normal traffic, because everything is tied up with this. You see, synchronization request, sync flood. We are seeing the same thing using UDP, flood out the victim side with UDP traffic. So this is what we are having as a attacks. Sync attack, where attacker sends so many requests to the bank. In similar case, if we are using the UDP, in case of the UDP as well, they'll say so many requests to the bank, and they are unable to handle those many requests, so which is one of the overwhelming and fulfilling their entire network capacity. And that is something called fragile attack. One of the weakness of course always with any type of computer system is true randomization. And how does a computer, which is by its true nature very logical, truly choose a random value? And This was a weakness in earlier version of TCP, where we have TCP sequence number attack. In case of Mitnick version versus Simoros, Mitnick exploited a very easy to exploit weakness in TCP, where he was able to hijack Shimomura's communication by guessing that the next TCP sequence number would be how that has been improved through patching and so on. But that just proved some of the problems here when it comes to randomization. We also have a man in middle attack, but I'm setting up an encrypted session. So can someone get in middle of that, be able to impersonate one side or the other side and be able to now have access to the data it communicate between two parties. So this is what are the common attacks we are having for the transport layer. So now we have discussed about this transport layer. So let's come and discuss about our next layer, which is a network layer. The network layer is really the heart of the communication, where most of the hard work happen as we send datagram across between different networks, both between hosts, but also in very many cases now between different network nodes along the way as well. The secret of the network security is to protect these datagram. A datagram is made up of data, all of the headers we put on so far, and now the IP headers. The IP headers, or we can also say the internet protocol, which is same as the IP headers. So both the way we can say as a IP header, or we can say as a internet protocol header. So it totally depends which IP version we are using. If we are using the IP version 4, it is 32-bit. If we are using the IP version 6, it's 28-bit. And there are some similarities between the header. For example, they both have what we call a time to live or hop limit, as it's called in version 6. This prevents the package from traveling around the world forever and never finding a home. Instead, once it runs out of time or exceeds a certain number of hops, then the datagram will just be dropped and forgotten about. And the IP address, of course, a logical address, not a physical address, quite different from a data link, which is more of a like a true physical address. We can assign IP address to a machine, and now we will be able to route this traffic through the various network segmentation using things like IP, ICMP, IGMP, and ICMP ping being used, of course, in internet control management, that is ICM, and that is IGMP being used in things like multicasting, where I'm going to send a traffic from one person to many using internet group management protocol. We can also do encryption down here in the network layer. This is while using the IP security, we can also say IPsec. However, it is very important to know that the purpose of IPsec was to establish the connectionless integration over the network. Connectionless integration over the network. It was to prevent some of the problems we had of IP spoofing. So it is very useful if we are having the IP spoofing attack. For example, IP spoofing is to alteration of the data as it was sent. So the first part of IP spec was going to look at the authentication header, that is also called AH. So when I sent traffic unit the IPsec and in authentication header mode, I insert authentication header in between the IP and the transport layer. And what the authentication header does is exactly what the name says. It authenticates the content of the IP header. In the content of our IP header, we have source and destination address. We have the integrity check. So It makes sure that a person is not able to spoof or pretend to be somebody they are not. This is one of the reasons why the early days when we use the network address translator, that is NAT, that is called as natting, it won't work in IPsec, because with netting we were converting that internally used IP addressing into an external word, but this allows us then to send our traffic with assurance of who it comes from. So we have spoof of the origin of the traffic, but we do not have confidentiality if we are in authentication header mode. If I want confidentiality, I need to use encapsulating security payroll mode. Now there are two types of ESP, that is encryption security protocol. So there are also the same thing as AH, that is authentication header, but we don't really need to go for authentication header because the traffic is not encrypted anyways. But IPsec and ESP transport protocol insert a ESP header after IP header and the before transport layer, and it does exactly what authentication header did as well. It authenticate that IP header. Now it encrypt all of the data after that. The transport session presentation application and data itself are all encrypted, so the person observing the traffic would only see the traffic is going from this original to a destination, but they won't be able to see any more detail about the traffic or what type of traffic it is. So this is what the encapsulating security payload do for us in our in our network layer. So if we are talking about network is how the packets are getting transporting to one from the network, from source to destination. So this is what we have covered most of the layers. Now only last two layers are remaining, that is the physical layer and data layer, which we'll be going to discuss in our next session.